All right, so let me show you what we did in class today for you tennis players. Okay, so we pulled up the aluminum and tensile test. So the first thing you want to do is draw the graph on your paper. So you're going to draw your graph. Okay, then you're going to label the points that I want to tell you. Okay, this is your second problem. The first problem you did with the sample numbers that Project Lead the Way gave you. All right, so let's go to here. Now let's find the proportional limit. Proportional limit is right there. So you want to write that down. So the force proportional limit, I use PL, is around 560. Okay, the elongation at that point is 0.0032. All right. Now, that's your recording. I'm recording. All right. Now, we want to also find the yield strength. That's around 600. So we're also going to write that down. It's around 600 pounds, and the elongation is 0.0035. We also want the ultimate. The ultimate is about right there, so we're going to write that down. The ultimate strength, the force at that point, is around 652. And the elongation is 0.0087. And then you have fracture. Fracture is right there at 488. So it's 488, and the total elongation was 0.0157, and that's inches. So I'll show you what I have so far. It's right there. And I'm writing fast. You want to do something a little bit neater, of course. There's pounds, 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 pounds. Pounds force, because that's context. All right, now, we also want to know the slope of this. So let's highlight this area. Okay, so the slope, of course, is rise over run, or the F2 minus F1, and elongation 2 minus elongation 1. I'll show you what I'm writing here. Okay, so F2 is around 550, take away 100, so that's 450 divided by the difference in elongation, which is about 0.0021. Okay, I'll tell you what that serves, what purpose that serves in a minute. We also want to know the area under here. All right, so now we'll come back to that. All right, so what Project Lead the Way wants is the stress at each of these 3 points. So the stress at each of those 3 points is given by this formula here. All right, so we'll say proportional limit. That's where it's still linear, no deformation. So that's force over the original length. So our original length is with our diameter of, so we gotta look, 0.188. And our original length is 1, and that's in inches. So it's going to be pi r squared, or pi times 0.188 divided by 2 squared. Okay, I'm going to let you calculate that. All right, so now for our proportional limit, so what I'm writing here. Okay, so we want to get our force for that at about 560 over our area. Okay, for our yield strength, I'll go a little faster than in class because you can stop this. 600. Okay, I've corrected out a little 60, so 600. Okay, pi 0.188 squared over 2. And then the ultimate was around 652. pi times 0.188 over 2 squared. Okay. Project Lead the Way also wants the elastic limit. The elastic limit is our slope times our original length over our original area. And this is because elastic limit is stress over strain. Okay, so this is just a formula rearranged to fit the graph. All right, so we take our slope, which we calculated, and we put in the original length of 1 and our area. They also want us to estimate the resilience. So resilience is 1/2 our stress at the yield point and our strain at the yield point. And strain at the yield point is our deformation at the yield point divided by our original length. Okay, so you can get those numbers, plug those in, and there you have it. And you'll have 2 of those. The first one is from this numbers from Project Lead the Way, so you have to kind of find those on the Project Lead the Way page, and you're doing the same thing. And then here's problem number 2 for aluminum, and I think that teaches the material and cleans it up and makes it very understandable.